A very good morning, students. Welcome to the lecture series on operating systems. So far we have discussed about uniprocessor scheduling algorithms. In the case of the uniprocessor scheduling algorithms, an uniprocessor with a single queue. In that scenario, we discussed about the preemptive and non-preemptive scheduling algorithms, and later on the point, we discussed about multi-level queue and multi-level feedback queue scheduling algorithms. In the case of the multi-level and multi-level feedback queue scheduling algorithms, a single processor with a multiple number of ready queues are there. Okay, now in this session, we are going to discuss about multiprocessor scheduling algorithms. In the case of the multiprocessor scheduling algorithms, multiple number of CPUs will be there. We need to balance the load among all the processors, because to achieve the benefit of having multiple number of the CPUs, it is highly essential to share the load among all the processors simultaneously. To do that, we need to pull some process from one processor to another processor, and it is referred as migration. We are going to discuss about all these concepts in this session. Okay, students, listen. First of all, what is a multiprocessor scheduling? In the case of the multiprocessor scheduling, there are multiple number of CPUs which are ready to. In the case of the multiprocessor scheduling, there are multiple number of CPUs are available. We need to share the load among all these processors. The implementation of multiprocessor scheduling is somewhat difficult than implementation of uniprocessor scheduling. The multiprocessor scheduling has been divided into two kinds. One is asymmetric multiprocessing and other one is symmetric multiprocessing. Coming to the asymmetric multiprocessing. In the asymmetric multiprocessing, there is a master-slave architecture. Coming to the master-slave architecture, there is a master server will be there. This master server is meant to carry out IO processing and process scheduling. In addition to that, if it is required, the scheduling also can be taken care by that particular master server itself. So, all other servers will serve as regular process for the execution of the instructions only. So, the scheduling decisions, IO processing, process scheduling, and everything will be taken care by the master processor only. Due to that reason, the information sharing will become very much easier in the case of the asymmetric multiprocessing environment. But this becomes very much difficult task in the case of the implementation of symmetrical multiprocessing environment. Coming to the symmetrical multiprocessing environment, there are multiple number of processors will be there, but all processors will maintain its own ready queue. So scheduling becomes very much difficult task for all processors. Here, every processor will serve as an individual computing machine. Means there is a high demand for information sharing and data sharing. Okay, as a part of that, it is highly essential to establish the private queue among all these processors to balance the load among them. Coming to this, every process have some affinity towards the processor. Likewise, every processor will also have some affinity towards the process. Okay, so this particular process affinity is referred like, for example, if any of the processor has spent some of its CPU cycles, IO devices with the execution of the process, then it is referred as affinity. This processor affinity has been divided into two kinds. One is soft affinity and other one is hard affinity. Coming to the soft affinity. In the case of the soft affinity, operating system will be permitted to move one process from one processor to another processor. Means it is highly possible to switch the process from one processor to another processor. Means load sharing will become so possible in the case of the soft affinity. But in the case of the hard affinity, the sharing of the load will become difficult, because every processor will have high affinity towards the process. Means it allocates more number of CPU cycles, more number of memory cycles towards the execution of the instruction. Due to that reason, the processor will not permit the operating system to move the process from one processor to another processor. Due to that reason, the hard affinity doesn't allow the load balancing when compared to the soft affinity. Load balancing is made possible when the work has been carried equally or uniformly across all the computers or all the processors. It is made possible only if it is having establishing the private queue among all the processes to execute on those machines. Further, it is essential to balance the workload among all the processes to utilize the benefit of the multiprocessor environment. And it is possible only with the two kinds of the migrations. One is a push migration and other one is a pull migration. Coming to the push migration. For example, there are two kinds of the processes. One is One is P1 and other one is P2. P1 is fully loaded processor. P2 is lightly loaded processor. P1 is a fully loaded processor and P2 is a lightly loaded processor. We need to make use of the services of the P2 also. Now, P1 is going to push some of the load to the lightly loaded processor. Then it is referred as a push migration. Means heavily loaded processor moves some of the processes towards the lightly loaded processor. Then it is referred as a push migration. But in the case of the pull migration, the lightly loaded processor is going to capture or is going to collect some of the processes from the heavily loaded processor. Then it is referred as a pull migration. Okay, students? Now there is a question. What is the kind of relationship is between affinity and migration? Push or pull migration. Coming to that, the load balancing can be carried through either pull migration or push migration, and it is having what kind of relationship with the affinity? That is indirectly proportional. Means if the higher affinity is there, then load balancing will becomes very much difficult. So it is very much clear that load balancing is indirectly proportional to affinity. Means if the processor is having high affinity towards the process, then balancing of the load is not at all easy. Likewise, if the affinity is minimum, then the load balancing becomes very much easy. Okay, students, these are the things are related to the multiprocessor environment. In the case of the multiprocessor environment, multiple number of CPUs will be there, and scheduling is highly essential in the case of the symmetrical multiprocessing environment, because in the case of the symmetrical multiprocessing environment, every processor maintains its own ready queue. Therefore, load balancing becomes highly essential in the case of the symmetrical multiprocessing environment. In the case of the symmetrical multiprocessing environment, every processor has some affinity towards the process. Due to that reason, the process should not allow the operating system to move the one process from one processor to another processor. Thank you, students. Thank you for listening to the lecture.